Hey friends, I'm here at Roaring Springs Water Park today and I'm feeling extra brave. I want to start my day off by riding the steepest water slide in the park. What makes one slide steeper than another? Maybe I can use some mathematical thinking to help me figure this out. Let's compare these two slides. Which one's steeper, Bayou Bliss or Riptide Rapids? How do you know? The steeper slide is Riptide Rapids because it's the one that's closest to being straight up and down. The less steep it is, the closer it is to being flat horizontally. So just by looking, I can tell Riptide Rapids is definitely steeper than Bayou Bliss because it's closer to being straight up and down. If we put it on a coordinate plane, it might be easier to compare the difference. For those first two water slides, it was pretty easy to tell which one was steeper, just by looking. These two, however, are more similar. We're going to have to figure out a different way to determine which one is steeper. Luckily, math has an even more precise way to describe how slanted objects are. We can calculate just how steep the object is, then compare those numbers. We call that finding the slope. The bigger the slope, the steeper the line. The smaller the slope, the flatter or less steep your line. You can lay the object on a coordinate plane, then draw a line along it like this. We'll need to calculate the slopes of these slides in order to determine which one is steepest, so I can show just how brave I am. To calculate the slopes, the first thing we need is the definition. Slope is the steepness of a line determined by the ratio of the vertical change along the y-axis to the horizontal change along the x-axis. Let's break that down. A ratio, well, that's also known as a proportion and can be written as a fraction. So, slope is a fraction. Okay, and in that fraction, there's two parts. The first part is the vertical change along the y-axis. Verticals up and down, so the numerator of our fraction is how quickly the line rises up. The denominator of the slope fraction is the horizontal change along the x-axis, which is how quickly the line runs side to side. So to calculate the slope of a line and find how steep it is, we determine its rise and put that over its run. But how do we do that?
This line represents the slope of Riptide Rapids. Let's draw a right triangle that has its hypotenuse on the line. We can have it lay directly on the lines on the coordinate plane, and its vertices can be on points, like this. How many units tall is this triangle? 1, 2, 3. It's 3 units tall. And how many units long is this triangle? 1, 2, 3, 4. It's 4 units long. And since the hypotenuse is the line itself, that means the hypotenuse of this triangle has the same slope as the line. For the rise in the slope fraction, what do you think we'll use? How tall the triangle is, or how long the triangle is? Yes, rise is how tall the triangle is. The triangle is 3 units tall, so we put 3 as the numerator of our fraction. That means run is the length of the triangle, so the denominator of the slope fraction is 4. That gives us a slope of 3 over 4. Does that fraction need to be simplified? Nope. No number divides evenly into both 3 and 4, so the fraction is as simplified as it can get. But what if you picked different starting points? Let's draw another right triangle on this same line using these points. A much bigger triangle this time. Its hypotenuse is still on the line, so let's determine the slope once again using the rise and run of the triangle. Count out the rise. The triangle is 6 units tall, so that's the numerator of our fraction. Okay, same thing for the length of the triangle. Count out the run. 8 units, right. Let's put 8 as the denominator of the slope fraction. Can 6/8 be simplified? Sure seems like it. Go ahead and do that now. 2 goes evenly into both 6 and 8, which gave me 3/4 when fully simplified. Interesting. We got the same answer both times. What does that mean? Well, there's something special about these two triangles. Do you know what it is? These are similar triangles.
Similar triangles are the same shape, but not the same size. Since they're the same shape, that means their hypotenuses both have the same slopes. So, no matter where you draw your triangle on the line, and no matter how big it is, you can use a triangle to calculate the slope of a line. In fact, we call these slope triangles. They're right triangles with their hypotenuse on the slope of the line. Slope triangles are right triangles whose hypotenuse lies along the line we're measuring. The vertical leg of the triangle represents the rise, and the horizontal leg shows the run. When we measure the rise and run, we're really just determining how far the line goes up or down and how far it goes side to side. For example, when we looked at the ride Riptide Rapids, we found that the rise was 3 units and the run was 4 units, giving us a slope of 3/4. Cool, but we only figured out the slope of one of those water slides. What's the other one? And how do we know which is the steepest one so I can write it?
Try calculating the slope of Waterfall Canyon yourself. I've already added the line and slope triangle on the coordinate plane, so the first step is done for you. You need to count the rise for the numerator and the run for the denominator of the slope fraction. The vertical height is 4, so that goes on top since it's the rise. The triangle is 6 units wide, so that's the run on the bottom. Now simplify. 4 and 6 both divide by 2, so the simplified slope is 2/3. Have you noticed that Waterfall Canyon slides down a different way than Riptide Rapids? The Waterfall Canyon line slides down from left to right, while the previous line went up from left to right. Slopes can be positive or negative. Waterfall Canyon has a negative slope because it goes down from left to right. Riptide Rapids has a positive slope because it goes up as we follow it from left to right. So that means Waterfall Canyon's slope is negative 2/3. That means there's one last step when we calculate the slope of a line. We have to determine its sign. Great, now we know Riptide Rapids has a slope of 3/4 and Waterfall Canyon has a slope of negative 2/3. So which one is steeper? The steeper the line, the greater the slope. So we need to determine which fraction is the greatest. The first thing is to calculate the absolute value of each slope. We put the absolute value bars around each slope like this and evaluate. The absolute value of 3/4 is 3/4. The absolute value of negative 2/3 is positive 2/3. Now we compare those two fractions. Remember how to compare fractions? If not, check the video in your guided notes. Here's a quick refresher. To compare fractions, their denominators must match. Ours are 4 and 3, not the same, so we find the least common multiple. How about 12? That works. Multiply the numerator and denominator of the Riptide Rapids fraction by 3 to get 9/12. Multiply the Waterfall Canyon fraction by 4 to get 8/12. Now compare the numerators. 9 is greater than 8, so the first fraction is larger. That means Riptide Rapids is steeper than Waterfall Canyon. Okay, Misty Mountain is the last slide left to compare. You start this one. Draw a slope triangle, count out the rise over run, then simplify the slope fraction if necessary. Here's what I did. I drew my slope triangle and got a slope of 5/6 because the line rises 5 vertically and runs 6 horizontally. Since it goes down from left to right, the slope is negative. Negative 5/6. There's no need to simplify, so that's the slope of the line. Next, we need to compare Riptide Rapids and Misty Mountain. Do it on your own first, then compare with what I got. Riptide Rapids has a slope of 3/4 and Misty Mountains is negative 5/6. Remember to use absolute values when comparing steepness. So, we're comparing positive 5/6 to 3/4. With a common denominator of 24, we get numerators of 18 and 20. 20 is greater, so Misty Mountain is actually the steepest slide at the water park.
Now that I know how to compare the steepness of lines by calculating their slope, I'm off to ride Misty Mountain. In the meantime, you finish the notes, do the simulation activity, and work on the practice levels. The water park proves it. Math is everywhere. Keep exploring.